My name is Sharik Aziz and I am teaching chemistry in Syed Hamid Senior Secondary School, AMU Aligarh. Today's topic is hybridization. Hybridization is the process in which you can see here intermixing of orbitals having slightly different energies and shapes and redistribution of new orbitals having identical shapes and equivalent energies. First of all, you have to know what is orbital. Orbitals is the place where electrons are accommodated according to the Hund's rule, and there are four types of orbitals: S, P, D, F. But in class 11 we are taking only the hybridization involving S and P. So the shape of the S orbital is spherical and P orbital shape is dumbbell. Okay, and P orbital are on three axes: X, Y, Z. So these orbitals can change their shapes and energies. For that we are going to take an example of carbon atom. You know that carbon has special property called catenation and carbon is tetravalent. But if we see the electronic configuration of carbon, there are only two unpaired electrons for the bond formation. That means it shows that it's a divalent, but it is in the ground state. When it becomes in the hybridization, in excited state, the 2s orbital redistribute their energy and shape and merge into the p orbital, and according to the Hund's rule the electrons jump into the p orbital. So it is hybridized. S and P hybridization. SP hybridization are of three types: of hybridization. The first one is SP, SP2, SP3. As you can see, there is only one S character and one P character. That means S character is 50% and P character is also 50%. In second, you can see there are one S character and two P character, and you can see in the third one S character and three P orbitals are involved in this hybridization. So we can explain the first one by the example or the structure. SP hybridization. For example, formation of acetylene means carbon-carbon triple bond C2H2. Here you can see the hybrid orbitals are on the opposite side with the degree of 180. So the geometry is linear. Here is the structure of acetylene. Two carbons, orbitals overlapping head by head and form sigma bond. and hybrid orbitals overlapping with hydrogen bond also form sigma bond, and the unhybrid orbitals overlapping side by side which form pi bonds. Another pi bonds. That means it has two pi bonds and one sigma bond. The next hybridization is sp2 hybrid. sp2 hybridization. For that, C2H4. You see that carbon-carbon double bond with each carbon has two hydrogen atoms. Here, geometry is trigonal and planar. This sp2 hybridization contains one s orbital and two px and py. The structure is the one carbon atom orbital overlapping with the another carbon atom form sigma bond, and other orbitals overlapping side by side form pi bonds, and other two hybrid orbitals overlapping with hydrogen s orbitals form sigma bond, same as the other carbon atom. So it contains two bonds, one sigma and one pi bond. Okay, so the next hybridization is sp3. sp3 hybridization. For that, we have an example C2H6. C2H6 is, you can see, carbon-carbon single bond, and each carbon contains 3 hydrogen atoms. In this, you can see one s orbital and 3 p orbital, px, py, pz. In this, you can see that one carbon atom is orbital of one carbon atom is overlap head by head forms sigma bond, and other overhead with hydrogen atom, same as for the other carbon atom. For geometry, we have an example of methane. The carbon atom has orbital in 4 corners, headed towards the 4 corner. That's why the geometry is tetrahedral with an angle of 109°28. So students, that's all for today. Thank you.